Long. A bit. All right, everybody. We are getting this show on the road. It is 7:01. We're a minute late. Uh, what's going on, everybody? It was 95 last week. What the heck was that? Yeah. Come on, it was hot as hell in February. All right. Welcome to Astronomy on Tap. My name is Aaron. I have Michael to my left. Adam and Brian are running the show over here. Erica and Jasmine are down in front. You'll see Jasmine just here in a second. Tracy is here. She's giving a talk, original organizer and co-host. And Thomas is online. Caleb is in Kansas. He was here for a bit. What was that, a week or two ago? But yeah, that's us. Are there any first timers out here tonight? First time to Astronomy on Tap? Kyle, seventh first time, respect. Oh, Sam does the trivia. We'll see about it.
He's unforgettable.
I saw a couple hands for first timers. It's Kyle's seventh first time, so sixth first time. So he's doing something great, I guess. But for the first timers out here tonight, Michael, what is Astronomy on Tap?
It's a worldwide phenomenon, as you can see on this map. It gets me every time. For those who have been coming for a while, there was an immediate jump to this. I don't know why we added it. I think Sam did it to throw me off. But there we are, the yellow dot amongst the worldwide map of AOT. But what separates us from the rest? Well, interesting, hopefully. You all will leave here today learning something new. And I think especially today. We have a different kind of event today than our normal run, but we're focusing on the interactive part today. So you always get to ask questions, but today we're doing almost like a panel style. We really want to emphasize the questions today because today's topic is, of course, the Comet 3I Atlas that's going through the solar system and is still in the solar system, right? Yeah. Yeah, it still has to go by Jupiter, right? Or something like that? Yeah, it still has to. So it's still hanging around for a little bit. But yeah, it's on its way out now. It passed by the sun, its closest approach. So start getting your questions or anything ready that you may have already, and then hopefully after Tracy's talk, then if you have anything more, we're happy to hear it. So that's today's focus. And then fun, hopefully not only the talk, but if you want to stick around for our trivia afterward. We've got, we haven't had them in a while, but we've got the Lunar Orbiter prints back for our top prize. Robert Reeves has given us now all of the ones he had, so they're going to be our top prize for the next year probably, at least. And as always, please sign up if you haven't already for our socials here, and as well as our email list, which is corrected this time.
It
Last
works.
time.
I checked 5 times.
Yeah. Last time, if you scanned that, it took you to like the developer side of the page, which was an uh-oh. Now you will get the proper form to fill out if you want to join our email list. And yeah.
This month's feature, we are featuring space photos that everyone has taken, or people have taken on their own. This one comes from Austin Wallep, Big Bend in December. Nice, clear, crisp winter sky. Darkest skies in Texas and some in the world. But if you got a photo you want to see featured, send it to Sam Hart Helio, I believe, at gmail.com. You'll see the email in our next break. And then we have one more photo.
Is Austin in the room, by the way? There you are. Thank you for that photo. It's great.
Thanks, Ben. And then from our resident photographer, Lee Childers, took a great picture of the lunar eclipse.
That's incredible because it was so cloudy in San Antonio, but I guess just that far west, the sky was just nice then over there?
Was it cloudy or did you get a hole?
It was, I blew out the junction because that said it was going to be clear.
Right,
I woke up at 4 and it was cloudy, so I just hauled ass west until it wasn't cloudy anymore.
right.
Over on the side of the road.
That makes sense.
When in doubt, just haul ass west.
Yeah. Well, especially at this time of year, because all of the clouds are from the Gulf, so you just got to drive away from the Gulf until you're in clear sky. All right.
Tonight's lineup, so since we have the one talk today, we're going to go right into Astronomy in the News with Jasmine Singh, and then we're going to have our feature of the night, What We Know About the Third Ever Known Interstellar Object 3I Atlas by Dr. Tracy Becker with extended Q&A. There's the number on there if you want to text your questions. If you have a question, you can text Michael, I guess, little preemptive questions. But then we're probably going to do a little more live discussion type, taking questions from the room, raise your hand type stuff. And then classic trivia. We'll see what Sam has to offer us this month. And then without further ado,
Yes, we will get right started. Please welcome Jasmine Singh with Astronomy in the News.
I always forget. Every time. Every time. I should, though. We should do that. Okay, hello, everyone. Happy March. For the band kids, it's March 4th. If you know, you know. Like one person left. That's all that matters. So yeah, today I'm doing a bit of an extended Astro News, so hopefully you guys like it. We'll be talking about the blood moon, Artemis 2 updates, dark matter galaxies, and more. And this is a picture, a beautiful picture someone took. I mean, it's in black and white, but it is the blood moon, so very beautiful. Oh, the other way. Okay, Caleb finally taught me how to do this, so I know how to get this image now. Yeah. When he visited, I took the opportunity to ask him. So I know how to get this image now, but I still don't know where things are, so I'm very sorry. Eventually, I'll get it. Okay, so for March, the best dark sky window for viewing is around the new moon, which is on March 18th, roughly. Planets that we want to look for, Jupiter is going to be very big and bright in the evenings. And Venus and Saturn are pretty low in twilight, so you won't really see them like later at night. But they're going to have like a little conjunction happening around March 7th to 8th. So if you want to see them close together, that's when to look. As far as constellations go, Orion is saying goodbye, which is sad because that's my favorite. But yeah, it's setting in the west, so catch it when you can. And Leo is rising in the east and the southeast. And then you have Taurus and Gemini in the west around 10 p.m. And you can kind of use the Big Dipper to sky hop to see different things like Arcturus and is it Spica? Okay, pretend I said that. And then if you want to look at deep sky objects, we have the Beehive cluster, or M44. It's in Cancer, and it's a great, easy cluster to view between Gemini and Leo, but you have to use binoculars or telescopes to do that. So, like I said, eventually I'll be able to point to things, but just pretend I did this time. All right. This is news to me, so I will be talking about Project Hail Mary. So, it is releasing this month. It's a highly anticipated movie based on the novel by Andy Weir. Is that how you say it? Okay. He's the author of The Martian, and it starred Ryan Gosling. He's going to be playing Ryland Grace. It releases on March 20th. I was not paid to say this, but I'm really excited for this movie, so I had to talk about it. For those of you that don't know the story, I'm going to give a brief, no spoilers, synopsis. So basically, a man wakes up light years away from Earth. he has a coma, and he's on a spaceship. He has amnesia, and he basically has to like piece everything together about like who he is and why he's there and everything. And he finally learns that he's on a desperate last chance mission to save Earth from a star-eating organism called astrophage. So basically our sun is dying and he has to save it. So buy your tickets. Again, I wasn't paid, but I'm really excited for this. So, all right. Lunar eclipse. We mentioned it. We saw a couple photos. It was seen across North America and other parts of the world on literally, technically yesterday. And the peak visibility was about 5 a.m. our time. So if you got up and saw it, you did, but we didn't really see it. So, and yeah, so if you didn't know, lunar eclipses are okay to view with the naked eye, unlike solar eclipses. And if you don't know, they occur when the sun passes directly, when the Earth passes directly between the sun and moon, and it casts its shadow on the moon. So that's what makes it look like this. This is from my friend, Andrew McCarthy. He's very famous. And he took a very beautiful photo. But for us, the reality was this. This is what I saw. I stayed up, and that's what I saw, and that's how I felt. I did have to make a joke out of it, so I made a joke out of it, and NASA saw my tweet, so yeah, this was what I saw in my mind. I don't know why, out of all of my tweets, this is the one that NASA ended up seeing, but yeah, it's always the stupid ones. Yeah. All right. Artemis 2 updates. So, unfortunately, it's delayed again. It was rolled back into the VAD. It's now scheduled to launch no earlier than April, so. Of what year? Allegedly, April, allegedly. So yeah, I'm not an engineer, but there was a helium flow issue that was fixed on the upper stage, and that was causing the previous issues, which made them have to roll it back. But basically now they're like changing the program structure and adding a new mission and adjusting kind of the step-by-step path towards a lunar landing to kind of reduce risk. And basically the big picture is that they want to standardize and test systems kind of closer to home. And the goal is going to be more reliable and frequent missions, which, like I said, allegedly, if we have money. Okay, more news. So, JWST, and I'm going to say it the way I say it, and you can laugh, but I say Uranus, so yeah. It mapped the upper atmosphere of Uranus for the first time. We got the first vertical view of its ionosphere. So that's pretty good news because we don't really know a lot about the ice giants. We've only flown by them once. We've never had a dedicated mission to them right now. So because of this, scientists are basically going to have a more detailed view and idea of how the auroras form, how the magnetic field influences them, and how its atmosphere has continued to cool since the 1990s. And basically, yeah, it's going to give us a better understanding of the ice giant planets and help us better characterize giant planets outside of our solar system. So exciting stuff. I hope one day we can go to it, but again, money and time. Oh. Okay. Also cool news, Hubble has identified one of the darkest known galaxies. And what I mean by that is basically this is one of the most dark matter dominated galaxies ever discovered. It was found to have 99% dark matter of its mass. If you don't know what dark matter is, it's basically a weird form of matter that doesn't reflect, emit, or absorb light. We don't really know a lot about it, and the universe is mostly made of it, so yeah. But this was a weird one. They hypothesized that most of its normal matter was likely stripped away from gravitational interactions with other galaxies inside the Perseus cluster. So yeah, that's a strange one. Here's some new images. I really like this one from Webb. It's called the Exposed Cranium Nebula. I like it because it looks like a brain. Yeah, so that's like, I don't know, you can make something poetic about humans and space, and we're made of star stuff and all that. This is a picture of the blood moon. I had to put one up there. And then this is a new picture of the Cat's Eye Nebula from Hubble. Okay, so we do not have First Friday stargazing. Unfortunately, it was canceled this week, so sorry about that. But SAAA, they always do their stargazing every Wednesday at sunset at Raymond Rimkus. And then we have First Fridays at Scobie at 6:30. This month is special. We have the Messier Marathon. It goes for a few days, but the peak observing day is March 20th at 6:45. And that's going to be at Fort McCowick State Historic Site. There's also going to be observing at Guadalupe River State Park on the 28th at 8 p.m. And then obviously we know if you've been here, Scobie does events every Friday at 6:30. So thank you.
All right, thank you, Jasmine. And hopefully South Yano opens up again soon, because we always love those observing nights as well. Hello? There we go. You? No. Who? Okay. Well, yeah. Sometimes this show goes to show turning it off and on again is always a good strategy. All right, because of our modified schedule, we'll do instead a 5-minute break today. Finally, we're using that 5 to 10 minute. And then we'll come back with Tracy's talk and then begin our discussion panel after that. So 5 minutes is 20. 7:20.
All right, everybody, break time over. We have our feature of the night, Dr. Tracy Becker. She started this thing. She started AOT back in 2017. She's a scientist. I don't know your official title actually at Sweary, but scientist over at Southwest Research, working on a lot of different things. She's my advisor. And she's going to talk about 3i Atlas tonight. So let's give it up for Dr. Tracy Becker. As is tradition, we have a drinking word. The word is uttered. You go woo and you drink. Tracy, what is the drinking word tonight?
Interstellar. So, yeah, it's gonna be rough, especially at the beginning. So brace yourselves, pace yourselves. As always, Astronomy on Tap is not responsible, so make sure you're driving home safely. I have a coffee, and so I get to be extra cool to everybody else. I'm not drinking currently, but I am drinking coffee instead. So, all right, let's do this. So, what do we know about the interstellar object 3i Atlas? So this is the third ever known interstellar object that we've ever seen in our solar system. It's not likely the third one to ever pass through our solar system, but it's the third one that we've ever identified and recognized as not being part of our solar system. And I'll talk a little bit about what that means and why we know that. But first, because the keyword is interstellar, I had to point out this movie, which just looking at the cover, I was like, oh, that's fun. It looks pretty Comet-like, so that's a nice little image to have. And also, I know that like the next generation after mine like loves this movie. But this is my only reference to it because I only saw it once like 10 years ago, and I don't remember anything else about the movie, except that they tried to go to a planet near a black hole, which that's cool for a movie, but not great for like reality. But that, you know, whatever. I like a good movie, so maybe I'll watch it. I'm feeling inspired. Okay. Well, especially now that we got this other new movie coming out, so we'll see. They all got nice people in them, so. All right, where do I have to hold this to make it stop crackling? Okay. All right, so what actually makes an object interstellar? So this is a picture of our solar system and where some people would define the edge of the solar system to be. Some people would define it here. There's a couple different boundaries that we think about, but our solar system, generally what we think of is is where our main planets live. So, you know, Mercury all the way out through Pluto, and the Kuiper belt is out here. Then we have this region called the termination shock. This is where the area where the sun's, the pressure from the solar wind starts to not be as relevant as the pressures from all the other stars that are also sending particles out through the solar system. So that's one boundary. It's a cool one. It's one Voyagers have passed through and New Horizons is about to pass through. So we're learning a lot about this boundary. But there are a bunch of other particles and comet-like material that's out in the Oort cloud that's also usually considered part of our solar system as well. And it's about a third of the way out to the next closest star, which is Alpha Centauri. So when we're talking about something being interstellar, we're really talking about something that's come from beyond this Oort cloud. So if it's an object that's from the Oort cloud, that would just be considered a comet, a long period comet, a comet that came, it's bound to our sun, it's part of our solar system. So this object and the others that have been detected have come out from somewhere, most likely way beyond Alpha Centauri. So we're talking light years in distance. So that's, I won't say it again, space. All right, so the prequel. So I told you guys this is the third ever known one. What are the other two? So the first one was 1I. You can guess, what does I stand for? Interstellar, very good. So 1I was the first, Oumuamua, which was discovered in 2017. And then 2I Borisov, which was discovered in 2019. And now, of course, we have 3I Atlas, which was discovered last year. I guess I should have put that, 2025. And so, so just to clarify again, so we're talking about our sun being here. This thing could be from anywhere in our galaxy, technically. Just had to travel over a really long time to get to where it's in our solar system now. But how do we know that? How do we actually know that it's interstellar versus just something that's within our solar system? We could think about it as maybe being like composition, maybe we look at it and say that looks weird, but there's lots of weird things. There's lots of things we haven't studied yet. So you can't really do it based on like what it looks like. The real way that we know for sure that it's an interstellar object is that we look at its trajectory. So we calculate after night after night after night, you kind of graph out where the object is and where it's going. And the main one that really is a dead giveaway for it being not part of our solar system is the fact that it's not bound to the sun. So all of the objects that are part of our solar system are on an orbit of our sun. They might be a really, really, really big ellipse coming all the way from the Oort cloud or the Kuiper belt, but they're bound to the sun. So when you do the math, you would find out that it's an ellipse trajectory. These other objects are not on an ellipse. If you do the math and you look at your, maybe senior year math class or early physics classes in college, the equations for a hyperbola or a parabola versus an ellipse, and you would see that actually you get something greater than 1 means that it's on a hyperbolic or a parabolic orbit, and that's what these things are. So Oumuamua was a close call. It was only 1.2, but this latest one is a 6.2. So this one was definitely not bound to our sun. This thing is making basically a straight path through our solar system in many ways. And you can see the other complicated part is that some of these other objects came from out of the plane of the solar system, came down through, and went out that way. That's also a good indicator that it's not maybe part of our solar system, but the Oort cloud is kind of all around us, so objects from the Oort cloud could make that trajectory. But certainly one that's screaming through the solar system at the speed of 3i Atlas and with a number 6 there, it's definitely not, it's like a straight line. It's not bound to our sun. So what makes this one so interesting? Well, I'm actually going to start with this bottom topic here because honestly, we can't see small objects from other solar systems. We have just gotten the technology now to start looking at planets, exoplanets. We have some telescopes that can see the biggest ones of those, but we're not studying individual comets or asteroids, which are really important objects in solar systems, including in our own. So that makes this thing like super cool all on its own. But the reason this one in particular is exciting is that we think where it might be coming from is part of the thick disk of the galaxy. So the thick disk, like we're kind of in this main plane, and that this one might be coming from a region that's basically a lot older. And so this might be a really ancient object. So it might be over 7 or 8 billion years old. And for reference, our solar system is half that age, 4.5 billion years. So what kinds of materials were available to solar systems 8 billion years ago compared to what was available 4 billion years ago? We don't know. That's what these kinds of opportunities actually get to teach us. And we weren't out looking for it. It came to us, so that's even cooler. And this one in particular is also really cool because we've known about it for a really long time. With the other two, we detected them, but they're on these orbits that are not bound to the sun, so they come in and we lose them right after that. We don't get to study them for a very long time. We also need to find them. Those ones came from that weird high inclination. They weren't part of the plane. We don't have a ton of surveys looking up like that. It's harder to detect ones that aren't coming from within the plane of the solar system. But this one was discovered, and it was discovered when it was still 4.3 AU away. So it was pretty far out, and it was already active, and that's why we were able to see it. So it's probably a pretty small object, but it already started becoming cometary at a really far distance away. And that is probably speaking to the fact that it is a really icy cold object that has probably never even seen its own star up close. So we think that because it was able to start getting activated that far out, it probably had all these ices that it trapped from its own Oort cloud or Kuiper belt or some really distant part of its solar system and got flung out by planet migration or just during the formation or whatever happened to it. But that object has probably not come very close to another star before. And so as it got close to our sun, it started sublimating really early. It had these ices and a lot of, especially what we'll talk about like CO2, that started getting active really far out because it's just the first time it ever got even a little bit warm. And so that was really cool because it meant that we could actually observe it for a long time. So this thing was discovered in July, I think July 2nd of 2025, whatever year we're in now, yeah, 2025. And then it made its closest approach to the sun at the end of October. And so we actually got a really long baseline of studying it before it even got close to our sun and then we were able to keep looking at it once it went past. Yeah, okay. So the other cool part about this is that we actually were able to gather a fleet of NASA missions to observe this object. So all of these missions up here, almost all of them, almost none of them were designed to look at comets. But they're out there in space, and they've got different kinds of instruments that are designed to study whatever they're supposed to be studying, asteroids and solar wind and all kinds of other things. But we got so lucky that their instruments are still so powerful that they can be used to suddenly just point at an interstellar comet and get us some cool data back. And so you can just see how many of these there are. Now, there was something else going on in the October timeframe when everyone was trying to use some spacecraft to look at it, and that was the government shutdown. So NASA was not actually actively able to be super involved, but all of the missions themselves were still operating. And so a lot of the missions were able to plan and actually make observations in that kind of short period of time. We're talking July to October. You had to identify where it's going to be, plan out how you're going to observe it, move the spacecraft accordingly. It's not an easy feat, but all of these different missions observed the comet, and that's pretty cool. And so what are we learning so far? So far, we see that interstellar object, 3I Atlas. It is extreme, but it's not exotic. And I'm gonna give a shout out to Dennis Bodwitz, because some of these slides are now from him on the science findings. But we see most of the same species that we see in our solar system: carbon dioxide, carbon monoxide, H2O. We're seeing all of those same things, but the ratios are very different than most of the comets we've ever seen in our own solar system. So things like way more carbon dioxide heavy compared to water. And so that's useful information. Again, where did that solar system form? Where did this object form in its own solar system? Are we weird? Is that solar system weird? Are they all different? We don't know. So what's actually the inventory of materials that this comet was able to be formed out of? And then those abundance, we see them strongly evolving with distance from the sun. So as these ices start to even get a little bit warm, they're getting activated in a way that's not exactly the same as what we've normally seen with our own comets in our solar system. But it's not like crazy weird, right? It's just sort of different, and we're learning a lot from that. And again, yeah, a lot of CO2, H2O, CO, but the fact that there was so much CO2 to H2O in this comet was what made it stand out a lot from our normal comets that we see in our solar system. And then we saw a lot of water. So the water started sublimating off, so it was going straight from ice phase to gas phase, that's sublimation. So we saw a lot of water coming off. It was really at a high rate of water production, and then it dropped off dramatically. Once it got past the sun, that drop-off was much steeper than we've typically seen in other comets. We don't know how to explain that yet either. Is it that because the surface is more ancient, that it traps it all back in more easily? Did it just blow off so much of the material that it, like, now it's kind of almost could be a dead comet? Like, if it came back around, we wouldn't see anything? We don't know, and so that's some of the stuff that's going with ongoing studies, which makes it fun. And then we got all kinds of cool data. So one of the really cool parts of this comet was that we saw a sunward-facing jet. So that means that all of this tail that you see here, this jet that you see here, this is actually pointing towards the sun. This was with James Webb Space Telescope, and this was with Hubble. So you can also see a little tail going in the sunward direction here. For reference, your typical comet, like Halley's Comet, this big, beautiful tail that you think of for a comet, that's going away from the sun. And it doesn't matter which direction the comet's going, that tail is in the direction away from the sun because the sun is putting out particles. It's called the solar wind, and that actually pushes the gases that have been blown off of the comet into the anti-sunward direction. So that's what we usually think of as a tail, but what we're seeing more prominently, especially when it was farther out from the sun, was this sunward-facing tail. And that just means that the part of the comet that was getting heated up was spewing out a lot of stuff in that direction. It also could mean that the solar wind wasn't very strong at that location because it was farther out, and so we weren't getting a lot of that beautiful back tail that we normally see. Okay, so hi, I'm Tracy. You all know me. I don't study comets, so why am I talking about this object? Not just because it's super cool and super exciting, but it's because Europa Clipper and JUICE were among two of the missions that actually did get to take observations of this object, and so I suddenly had to become a semi-expert on it. What's really cool about this is that Europa Clipper and JUICE got some really exciting angles of this comet. So Europa Clipper in particular was on the night side of the comet. So the comet was here at its closest approach to the sun. Europa Clipper was over here, and here's the sun. So that means we're seeing just the night side. So anything that we see with Europa Clipper is just emissions coming off of the comet. And it's just the light that's being sent out due to the materials in the comet actually collecting the sunlight and absorbing that and re-emitting some of that energy by breaking up the H2O into hydrogen and oxygen and other different processes happening on the comet. So it's comet-formed light. We're not seeing a lot of reflected light that you would if you were sitting on JUICE, perhaps, which is looking directly at the comet this way, where the sun is behind it and lighting up the comet for it. So we had two very different views, but JUICE and Clipper both carry two very wonderful instruments called the ultraviolet spectrograph that were built at the Southwest Research Institute. And so these are sister instruments that have two totally different perspectives of the comet. So it's one of the most powerful and unique ways we'll ever be able to look at a comet, and it was done by accident. So I think that's pretty cool. Not by accident, but the fact that it happened to pass through in between the two at the same time is very, very cool. So both instruments were observing at the same time, and then JUICE actually was able to observe for a lot longer as the comet went through. The other thing that's really cool about this is that this observation happened a couple of days after the comet's closest approach to the sun. And guess where Earth was at that time? Over here. So the sun looks small from this angle, but you can't actually point you can't point your telescopes on Earth in the direction of the sun to see the comet during the closest approach. So actually, almost all of the Earth-based telescopes were not able to look at the comet during the closest approach. So that gave these different space missions the opportunity to observe it when no one on Earth really could otherwise. Some of the helio-based, some of the sun-based instrumentation on Earth did look towards the sun, or they're supposed to look towards the sun anyway, and they actually caught some cool data of the comet as well. So that was the power of just having this incredible suite of NASA missions and European Space Agency missions out there for perfect timing for this to actually happen. So as we keep, developing more space missions and have them out there, we'll be ready, and we now know how to coordinate some of these kinds of observations for the next time when 4I object comes through the solar system. Unique instruments, unique angles. And again, remember, this object was discovered in early July. We had to plan the observations, have the spacecraft implement the maneuvers that were needed, all by October 31st. And some of the missions did it even earlier. So it was pretty cool. So the JUICE mission collected a bunch of data from a whole suite of different instruments. And that data actually, even though it was collected in October and November, JUICE was in a position where it couldn't send any of its data down because of the orientation of JUICE to Earth. And so all of that data just came down in February. So it's brand new. Pippa's looking through all of it. At least for the UVS, but there were several instruments on board that got some really cool, unique data. This is a press release that just came out a couple days ago showing what one of the JUICE instruments was able to see with the comet and some of the detail that it's able to pull out. So that's all going to be upcoming really cool press releases you can look for. Europa UVS, what we opted to do, we have this very, very narrow slit. And so you can't really take a picture with a narrow slit. You just get a spectra if you point that at a little object. So we ended up slewing the slit up and down over the comet. So that way we could actually build up an image, basically. So take data at each of those different positions as we're slewing up, and that gave us a whole kind of picture of the comet and the area around it. And I'll give a quick shout out. This is GV, and so Steven and Umer over there, they help run GV, so thanks for helping with this. And so we were able to create this beautiful map that Pippa put together of the interstellar. There we go. Of the interstellar object. And so some of this makes total sense to us. We see a bright spot of hydrogen right at the center where the comet is. So that's a lot of H2O getting blown off and getting broken into hydrogen and oxygen, so it makes total sense. We're seeing a ton of hydrogen right here. We see that anti-sunward tail, so we're close to the sun now, we're getting a good anti-sunward tail. We see the sunward tail, I guess. We also see this thing down here. So we're actually still trying to figure out what we're seeing. It's not exactly self-explanatory. And that's what's really fun. We don't know what exactly we're seeing. Some of it might be dust. Some of it might be material that got thrown off prior to its current position. We don't really know. And so that's been fun to start trying to analyze, but we don't have answers yet, which is cool. Okay, so what does all of this mean? Well, how do solar systems form, and with what relative abundance of materials? Are we the weird one? Like I said, are they the weird one? Are all of them weird? You know, what's normal? Is it to have a lot of CO2? Is it that ancient solar systems had more CO2 than they had water, or did that comet form in a weird spot in that solar system? We have no idea. This is our first data point that we have really from outside of our solar system. Like I said, we see exoplanets, but we can't see small objects like comets individually. This is just not possible yet with our technology. And then what happens to these ancient objects once they've been traveling for 8 billion years on their way to our solar system? You know, it's actually still getting exposed to all kinds of cosmic rays and different radiation as it goes through different star systems, even if it didn't go close to those stars. And then what happens to ancient objects? Oh, that says it twice. I think I had a different comment I was going to put there, but that's all right. But I'll just say it. What happens to ancient objects traveling on an interstellar journey? There we go. All right. So now let's address the alien in the room. Is this aliens? So hopefully I've kind of given you a little bit of idea, but I think you can always trust this core message of WWCSS, which of course means, what would Carl Sagan say? And, you know, Carl Sagan, of any scientist in recent history, wanted to find extraterrestrial life. He set up the SETI Institute. He wanted to find and understand if there was a chance for us to find life, explore life, interact with life. But he would also say extraordinary claims require extraordinary evidence. And what evidence is there? Well, I lost track of all the different random reports that I kept seeing about how these were aliens. And so I asked ChatGPT, and thankfully ChatGPT did say, there's no evidence, but here's what people keep citing as evidence. So I'm gonna just run through these, and then we're gonna open it up to questions about this or anything else. But I have some questions for you guys too. So for one, people are saying that this unusual trajectory, what are the odds that it came by all of our spacecraft? What are the odds that it actually came so close to Earth, even though the Earth was on the opposite side of the sun when it got closest, but you know, whatever. Now it's getting pretty close to Jupiter, actually, so I don't know why that would be what the aliens wanted to do, but okay. It doesn't look like a normal comet. Well, I've explained that a little bit, hopefully enough. It's got non-gravitational acceleration. I mean, we found it in July. We knew exactly where to point the Europa Clipper spacecraft and the JUICE spacecraft in October. It's going on a pretty normal trajectory, and every object has deviations, especially comets that are constantly outgassing material in non-uniform ways. So there's some changes to its trajectory, but it's pretty standard for what we'd expect for a comet. And scouting probes make sense for aliens to do, so obviously that's your core evidence. But yeah, I think I would ask the audience here, like, what might actually be convincing evidence that it was an alien spacecraft or spy probe or missile? And yeah, what philosophies all press is good press apply? Does it apply here? Does it not apply here? I don't know. That's for you guys to decide. So we can do that in the Q&A, and I will stop here. Thanks all.
No, that was. Yeah, so questions. There's a number on the screen if you want to remain anonymous. Here in a second, if we don't have any questions on the text line, we'll open it up to in the room. But who's the panel? We are the panel. We have someone who studies protoplanetary disks, so we know a little bit about things going on before planets form. Got a UV guy here, UV gal here who's been in the thing. Pippa. If we gotta do a phone a friend for Pippa, she does UVF stuff. She's looking at the data, and then I do objects in the solar system. So,
One thing
We have an interesting set of people here.
I wanted to bring up, because I know it's being conceptualized now, and I believe it's led by the European Space Agency, but it's the Comet interceptor mission, right? And they're trying to create a concept where if you can detect something like this early enough, where you can have a rocket that's already prefabricated and not the rocket, and then the spacecraft prefabricated and all that, you get the trajectory down pat, and then you send it up as quick as you can to intercept such objects. It's such an ambitious plan, but the plan is to have it ready by the end of the decade, so any future ones perhaps could have this type of close flyby of a spacecraft to it. So look for that on the horizon, because that'd be amazing, because obviously all of this was remote sensing. If we could have in situ or close by remote sensing, that would revolutionize what was shown here today. So hopefully. What?
Even like a parking lot.
Yeah. Even parking orbit is what Aaron said. So this is a very hot button topic right now in the field. So, but yes, let me.
So we've never done it as panel style, but ask questions.
I got to get the phone out. So for those of you that have texted in.
They do have,
No, you're the longest. Oh yeah, yeah. There's rings. Yeah.
Yeah. Don't forget Uranus spins on its side.
No.
Oh yeah, no, yeah.
Yeah, those are the real ones. But also, if you do see images that don't have them, it could be based on the wavelength that the data was taken at, because the rings are only reflective at certain wavelengths of light too. So you can also end up either underexposing them if you take a quick snapshot because they're very dark, or it could also be the wavelength that you're looking at. Could just be not as sensitive. But yeah, those are the rings.
And
Okay,
it
so the first question is
wasn't a ring discovered by Miriam? Yeah.
moon.
A moon. Yeah.
No, it was Uranus. Yeah. How will the Large Sky Survey Telescope impact interstellar object detection? Woo!
The one that just came online. I can't remember the name.
It's Vera Rubin. Yeah.
That was my question.
I can at least try to comment on it.
Well, yeah, you go ahead.
So the one thing to keep in mind with Vera Rubin is, one, yes, it would make detections like this easier. It is an optical telescope, so I can't comment on how easy it is to find these objects with an optical telescope. But the other thing is you also have to have people who are interested in digging that out of the data. There is a massive amount of data coming out of Vera Rubin every single night, and you either have to write algorithms that are actually designed to find these little needles in a haystack, or you have to give people the data to go through it manually, which requires proposals and people actually willing to do that work. So it depends on if and how many people there are to actually do that work. But if there are people, yeah, it would probably help quite a bit, because that's a
Yeah.
pretty dang good camera.
I don't know what it was that they just released, but there was some kind of early science release that just came out where they were highlighting the changes, which is what it's designed to do. It's designed to take an image of the sky and then come back to that same spot and see what changed. And it demonstrated, I'm not saying I believe them, but with what they said, it demonstrated different objects that changed, whether it's a supernova in a galaxy, active galactic nuclei, which I think is crazy, objects appearing in the solar system where they weren't before, and then, so, like, things pop up, but yeah, it's a matter of algorithms and then manpower, people.
And just one crazy fact about it, because I had to look up the exact number so I didn't say this wrong, but on one single night, Vera Rubin detected 800,000 previously undetected objects. So that's the level of how many more things we're going to be able to see with this survey.
5 million in the next couple years. I think you got to hold the bottom. Yeah, you got to hold it in a. Don't let go.
Don't move. Oh, well, this is going to be. Okay, well, I remember the next question. It was why weren't there any interstellar objects observed before 2018 or 2017? Sorry, and what's kind of leading the change on that? And I guess part of that answer is that these types of telescopes and viewing capabilities we have because of how small these objects are. Think about the size of a comet, right? And the farther you are from the sun, naturally the less light is reflecting to see. So you either would have had to have gotten very lucky for a serendipitous observation, or it would have just had to be abnormally bright.
And again, manpower, because you got to know it's there. Because I think 2024 YR4, I believe, is the letters in the number. The one that they thought was going to hit Earth, and it's not going to hit Earth, now it's going to maybe hit the moon. So when you find an object, once you know it's there, now we know what we know, and we can go find out what we don't know. You can go look back in time at archival data and say, okay, I know this object is here. If we track the orbit back in time, this telescope, this mission was looking here at this time. So you go find that data, and then you might be able to find that object. And they did that with 2024 YR4. They found data from 2016. We had no idea it was in that image, but once you go back in time, because now you know something new, you actually did find it, but there were, who knows why it wasn't detected because we're not looking for it. You got to know it's there. Or at least know you're looking for something you don't know is there.
Yeah, and in this case, it was a comet-like object, so it was actually became very bright. But if it's an asteroid-like object and doesn't come very close to the sun, you're not going to see it. If it was this object, but it was still out by Jupiter, we wouldn't have seen it. It's too small, it's too dark. So there's a lot of different factors that play into whether or not we can find them, but having really sensitive surveys is part of it. So 3i Atlas is called 3i Atlas because it was detected by the Atlas survey. So because we have these all-night sky surveys happening now, which we didn't really have pre-2000, now we're actually able to find a lot of them and then do what Aaron just described, which is have enough of repetitive images, have the computer power to actually see ones that are slightly changing in their position, recognize that those are not background stars, but are in fact asteroids or comets, and then go through and calculate that trajectory. Some of them could have a trajectory that made it look like they are bound to our solar system too, right? If it was a 1.1, not a 6, it's going to be harder to recognize that it was an abnormal object.
And this is, yeah.
Yeah,
Let's go to the room. Actually, let me see how far I can. If you don't mind coming.
Is it ever going to be possible to backtrack these objects and maybe identify a possible source solar system?
I think they did that with 3i Atlas, and I think all the others. The hard part is, what did it pass by on its way here? And that's the big unknown. Did it pass by a star? Because like 3i Atlas, how Tracy was saying, it kind of went like took a straight line. There's a slight bend in it. So that's gonna, and as I think most of us are familiar with, a tiny, tiny angle in space in decades is a huge distance in between here or there. And so we can go back to a point. And I want to say they went back like 200 million years or something with one of them. I remember they tracked these orange lines across the galaxy to say like, if the orbit was unperturbed, if it didn't pass something that made it move.
The sun enough times, it could be that it's lost most of those volatiles, most of those ices that would sublimate when it got closer to the sun. And then the next...
They have previously passed close to a different star.
Nope, okay. So I think the main thing to keep in mind is it would depend on how much it actually interacts with the materials in that solar system, depending on where it is, depending on when the star formed.
Event for a spacecraft. What is the advantage of something like this? You get to learn your instrument before you get there. Like you get to learn before you learn.
Yeah, absolutely. For Juice and Clipper, especially because they're not anywhere near their main science targets yet. They've still got like 4 or 5 years to go. This is a great opportunity for us to understand how our instrument responds to something that's more similar to a planetary object like we're going to study than usually for calibration and stuff in flight we use stars, which are just point sources, and their spectra are very different. So this was awesome for us understanding the instrument, and it raised a lot of questions that we're still figuring out. Lots of quirks to the instruments that we have to, now we've got an extra opportunity to figure out before we get to Jupiter. So yeah, it's been great.
She covered it. Any other questions? Should we ask our questions? Oh, there's a few more online. Okay.
I like this one because it's about, with the 3 objects, have they been in similar size and moving at similar speeds? Now I know with Oumuamua there's always that concept art of it being an elongated object, which was why it was so freaky when it first came around. And 3I Atlas, of course, is that more cometary structure. Now without being up close you can't see the definition, but you know, normal comets kind of have either somewhat spherical, or sometimes they can be contact binaries, like the 67P Churyumov-Gerasimenko, which the Rosetta mission went to visit a few decades ago. And, oh yeah, there it is. And can come look at that, can pass that around. And then as far as speeds, I don't know, Tracy, if you had that off the top of your heads, if they were very different, or...
I have it on my computer. But
Okay.
they're all fast.
This was the fastest, okay.
Fastest, and that's because of that trajectory
Right.
being so far.
Eccentricity is like pseudo speed.
It's really
Yeah. Yeah.
Yeah, but the 2 comets, so Borisov was also a comet, but Oumuamua was just that cigar-shaped, like, dark thing. So with comets, it's hard to say how big the objects actually are, because it's also a function of how much material is being outgassed. So we don't have a great estimate on the core size, but all of them have been small. I could get the actual sizes. But yeah, they're definitely worth studying, because now we have some stats, but they're all pretty different, but still small.
Is it possible to put some kind of a limit on whether or not an object of this size could be antimatter? I mean, there's like theories about the rest of the universe somewhere else being antimatter, right? And if it interacted with a lot of matter from the solar wind, then there would be a lot of energy released. But depending on how much radiation it's interacting with versus matter, it's not clear that you would see a large effect, right? So I don't know, has anyone like done that calculation? Just, no?
I mean, I think at a minimum it'd be a different signature. Yeah. Because there'd be, annihilation events and a lot of particle physics going on. And I think it's a good question, because it's like, well, something's coming from outside of what we know, how different could it be? And it kind of reminded me of, there's this idea of like, so like what if it was dark matter? Because there's this idea that Callisto is, a moon around Jupiter, Callisto, is so old. How old is it?
How old is it?
Callisto's so old that it's a great record of the solar system, and there's this idea that if you could have a dark matter object, it could penetrate straight through, and you would see a hole and then the the exit wound in Callisto. So there's ideas out there about like, so if something like this happens, where could we find it? What would it look like? So it's a good question, and it's a lot of what we don't know and what. So yeah, someone's got to do the calculation and find out what there is. Yeah, antimatter would go boom in the night. Like it would be a couple of particles would go big boom, big boom, big boom. There's a lot of solar particles out there.
So we had a couple questions on our slides for everybody that's here. So when did folks first hear about the interstellar object 3I Atlas? Or how did you hear about it? AOT. Go ahead, shout it out. Twitter. Aliens, right? Did anybody hear about it just as an interstellar cool object, or did most people hear about it because of aliens? So, okay. A mix? Okay. New alien. And what do you guys think about, we've got communications folks in the house, what do people think about the idea of like, all press is good press, or does that not apply when we're talking about an astronomical object like this one? I see some no's. There's a lot of misinformation.
Oh, I'll get started.
No, we don't have to talk about any one person in particular, but.
Oh, yeah, 3I Atlas makes my job more difficult because I have to combat misinformation already, and there's a lot of misinformation about this, so then I already have to tell people that, no, it's not aliens, so, yeah.
And I think with the bad press thing, it starts to ride the line of disinformation.
Yeah.
Avi Loeb is a scientist at Harvard, and he knows. But it has consequences because there was a sitting congressman that cited Avi Loeb in saying, Avi Loeb thinks this is an interstellar object. We should send Juno to go impact this comet. A sitting congressman who had no idea about what Juno's capabilities, how much fuel it even has to begin with if we want to consider the question, but then cited Avi Loeb to say, let's go do this crazy thing that, yeah, okay, in theory, great idea, but like, there's consequences to this kind of press.
And I'll also add, as somebody who does a fair bit of outreach outside of even this, when you have people who are trusted as experts in a field, whether they actually have the expertise to speak on a subject or not, because that's a whole different issue I'm not going to get into. When they are giving out disinformation or misinformation, it erodes the trust in the people who do have the expertise in that field, and it makes it much harder to build those relationships between the scientists and the public to actually get that information out there. And so, yeah, not all press is good press when it comes to science, because it just dilutes that information and it dilutes that trust.
And I'm glad Tracy invoked the great Carl Sagan, because he's a shining example. Nobody wants to find extraterrestrial life more than scientists, right? Because that's part of why we do what we do, right? We want to seek out the unknown. We want to explore things that have never been explored before. But you have to do it the right way. And part of doing it the right way is being thorough and figuring out all the pieces to the puzzle that is life. And, when these kinds of objects come by, you're going to have a lot of unknowns. And the first thing to do with those unknowns is categorize them and say, okay, well, what does this help us learn about that grand puzzle? You can't just jump and say, oh, well, we don't know what it is, so maybe it could be. No, you have to frame it, yeah, maybe there could be something, unnatural about it. But you have to say, okay, that's odd. How can we learn about it? So that maybe later down the line we can maybe find something that is truly unnatural. but you just can't make outlandish claims because then you become the famous story of the wolf, of the boy who cries wolf, right? If you cry wolf enough times, then nobody's going to believe you when you actually find that one smoking gun. So.
I'm going to put one more idea out there, but I loved Erica's response because I feel the same way. But the one thing I didn't think of, but that got brought up in one of the meetings I was sitting on, is also just the way that the public can interpret the idea that an alien spacecraft could be coming towards the Earth. And so for those of us who are maybe born before 1995 or so, might remember Heaven's Gate cults that actually killed many of them killed themselves thinking that they could climb aboard Comet Hale-Bopp by doing that. And so there's actually real world consequences to misinformation sometimes when it comes to science. And even when you think about like the sci-fi stuff when they did like, yeah. Are they the ones that burnt themselves? No, they all wore sneakers. They all wore Nike sneakers and took something and they were all in cabin. Anyway, we can talk about that later. But anyway, yeah, so there's real life consequences to that kind of information, especially something as potentially scary as the idea that an alien civilization is on its way to the Earth in 3 months. So something else to think about. On that happy note, what's the next question? Or other thoughts to any of these? What kind of evidence would convince you guys that it was actually an alien spacecraft? What would you guys need to see?
It literally landed. Lasers.
Shooting out of
Monolith? I like it.
Monolith, yeah.
like the
Lasers? Okay. All right. Any other questions? Any online? Any in the room? Last chance. Before trivia. Yeah. Okay.
I'm just curious, a lot of the research that was discussed tonight, it seems very monotonous and boring.
Sorry.
Well, no, I mean from an observational standpoint,
Yeah.
not the discovery. And I'm just wondering, at some point, AI is going to do a much better job of this. And I'm wondering, like, we're right in the crux of this burgeoning technology, and I'm just wondering how long it's going to be before it sort of like makes all this pointless. Figures it out.
Yeah, that's you mean when we're all out of a job? That's what you're talking about? Yeah. Well, I think so. Right now we have a decent partnership with the concept of AI. So like a lot of these big Vera Rubin surveys type of stuff, we're doing a lot of machine learning to identify. That's how we're able to pick up 800,000 objects in a night. We get all these observations, but then you use the machine learning or the AI to actually find the things, and then humans have to go and say, why is this one actually interesting still? Will there be at some point where the computers can just tell us this one's interesting because of this? I guess. That's a possibility down the road. But I don't know if we're there yet. I think right now, even AI would still need the inputs of why something new would be interesting before it can pull out its own scientific discoveries in that sense. So I don't know.
And also,
other thoughts on that?
Where is AI already? Except for LSST or Vera Rubin, it's people. It's real people doing the science. People say, go look at this thing. There's people in a building that make the thing turn and look at this thing. That data comes down, someone goes and looks at that thing, and then they do their research and then they write a paper. And so there's not a lot of, yet, I guess, AI in our spacecraft systems and in our space telescope systems. So science isn't there yet. We're not, I would say, 5-10% AI, not even. That's a big number in my opinion, but AI is not even in the systems yet. So it's still.
I'm wondering if that's by design.
AI just got here. What do you mean?
Well, it depends on your viewpoint.
But it's, I think, so for me, AI, right. And it has been being used by various scientists. Big data people have definitely been doing machine learning for quite a while. But AI as a whole and the machine learning is really just another tool in the repository of tools, right? Go back to the early times of people looking up at the stars, right? If they wanted to document something, they would have to look up and draw what they see, right? And that's how they found the planets, right? They saw the wanderers traveling across the sky that the stars weren't doing, right? That's how they found the first planets. And then you move to the age of telescopes where you can see beyond that, but still you'd have to draw. And then you got the photographic plates where you could hook up your telescope to the photographic plates, and then you have discoveries like all of Herschel Walker and all of that. No, right? No. Yeah. No. His last, William Herschel. William Herschel. And the plates, discovering all of these farther planets, and then you have discoveries of things like Pluto, right? So AI is that tool for us to discover, right? Back then, finding Pluto was an innovation, right? And right now, we would consider Pluto even a fairly bigger object. The AI is going to get us to find these tiny objects, whether it be comets or asteroids. It's really small things. So it's important, but it's a tool. It's a tool to help us humans find these things. It's not going to do. It's just going to be like photography was way back when, and then in the future, who knows what comes next. But it's just a tool to help us map out the local solar system and the universe in a way that we couldn't do before.
And I'll also add on, like in the theme of it being a tool, it's a tool that's very specifically designed to be good at pattern recognition and working with large-scale data that would be impossible or impractical for humans to process in their lifetimes or in a reasonable amount of time. In addition to that, when you're looking at specific objects, the sheer number of decisions you have to make as a researcher for an individual object is immense. And I don't think that's something that AI is going to be able to do anytime soon, because that's not what it's designed to do. It's something that we don't fully understand yet, and maybe some of the more computer-versed folks can comment more on that, how exactly it goes about making decisions based on its input settings and how those algorithms get changed as you change the training input and things like that. Right now, it's not really set up in a way that's good for replacing a researcher. There's a reason we have PhDs and we spend 4 to 8 years learning how to do this.
I just wanted to add that current AI techniques are statistical as well. So you usually need a lot of data that's already you already know what you're looking for before you get good matching. So if you're trying to look for things that you don't know what you're looking for, it's not very useful.
All right, any other questions or comments from the audience? If not, this has been a really great discussion. I hope you all enjoyed this special version of our Astronomy on Tap. Let's thank Tracy once again. And then, of course, Erica and Aaron for helping us out with the panel. And
Pippa and Adam.
Huh?
And Pippa and Adam.
All right, and Pip and Adam for their special guest stars appearances. All right, let's move on to our trivia portion. But for those of you that can't stay for trivia, please note our next AOT will be on April Fool's, and that is not an April Fool's, okay? We're not going to make you all come here and we don't show up. We wouldn't be that cruel. Now, will we prank you the day of? Maybe. But we will be here. The truth is out there. So if you can't stick around, we hope to see you then. If not, we'll take our usual 5-minute break to give out the answer sheets and writing utensils, and we'll be right back. Okay, who is ready to go for trivia tonight? No? Oh. I'm having a Berenstain Bears effect. No, that's Mandela effect. This compact binary in the Kuiper belt used to be known by what name? Its official name changed due to its relation to a Nazi faction. Uh-oh. It is spelled wrong. Thank you. It's Arokoth. A-R-R-O-K-O-T-H.
It's also not a compact binary, it's a contact binary, Sam.
Sam's really flubbing right now.
His homework tonight is to watch Contact.
That's Jasmine's homework, too.
Say that out loud. Michael.
All right. Question 3. Aaron?
What? Question 3. And then there were question 3. 3 men have died in space. Georgi, Yorgi, it's, the gears are turning. Dobro, yeah, Georgi, Victor, and Vladisov died during Soyuz 11. What caused this? A, capsule, what the fuck, Sam? Capsule depressurization, B, cabin fire, C, starvation, or D, unknown. If it's unknown, that's not.
All right, question 4. Darkness envelops me. Ooh. The Bootes void.
That's not how you say it.
It's Bootes? Bootes void is a region in space. I mean, you know, there's Uranus and Uranus. Come on. Is a region in space characterized by a stunning lack of what? Is it A, stars, B, meteor showers, C, satellites, or D, galaxies? What is the Bootes void?
Question 5. In 2019, this bright star dimmed suddenly. Scientists believe the dimming was caused by a large stellar ejection of a cold plasma, but a translucent spaceship cannot be ruled out. So says Sam. Was that star A. Antares, B. Arcturus, C. Betelgeuse, or D. Aldebaran? Yeah, but it's not. Beetlejuice is how we say it. Also, bonus, write it next to the letter because we have a bonus question, and the bonus question goes in the bonus section because that's where the bonus question goes. This goes next to the letter for half a point. Has it returned to its original brightness? Yes or no? You can write a Y, white. You can write a Y or an N.
All right. Question 6. Sad songs. Epitomizing teen angst, the song Black Hole Sun, Won't You Come, was released in 1994 by which popular grunge band? Is it A, Alice in Chains, B, Nirvana, C, Pearl Jam, or D, Soundgarden?
Hey, hey, how are you? It's Pearl Jam. That's Eddie Vedder. If you want to sing Eddie Vedder, you just mumble some vowels. Hey, hey, how are you? Does anybody need a question repeated?
From 1 to 6. Speak now or forever hold your peace.
Going once. Going twice. Sold to the bonus section. The bonus, and this goes in the bonus section because this is the bonus question. During Operation Plum Bob, a series of nuclear tests in Nevada, a manhole cover was accidentally launched high in the sky, never to be found. How fast was it moving? Answer in miles per hour. Closest answer awarded credit. Bottom text, the manhole cover was never found, and its velocity is well above escape velocity, leading some to believe it was sent into orbit. Erica has something to say.
If you happen to only know this in kilometers per second, for some reason, we do also have that conversion written down, but preferred miles per hour. Thank you.
We can convert. And then whenever you're done, please bring up your answer sheet and your pen, please. If we gave you one, we need the pens. We are poor.
Is everybody turned in their answers? Okay, let's see. We're going through. Y'all did pretty good tonight. Pat yourselves on the back. Except for
Don't say it. Don't say it all.
one of you is going to have to come up to us and discuss, because you didn't do so hot. But the rest of you. Okay. We're doing things interesting tonight, but first we got answers.
Question number 1, name that moon. Sharon.
Yeah, sounds
Did
like
everyone-
Sharon to
did
me.
anybody get it wrong? I think everyone got it.
Somebody did get it wrong.
Everyone got it right.
Everyone, very, no?
Everyone but
Was it the bad one? Oh,
the online spirit of Caleb will haunt you. But it's fine. He'll just tell you things about space.
all right. Question 2 was about the Arikoth, spelled wrong, by the way. It used to be called Ultima Thule. Thule.
I thought it was Thule.
Ultima Thule means distant world, and that was what would have been populated by the Aryan race, but thankfully that never happened, so, you know.
Fun
Aryan.
Fun facts by Sam. Question 3, how did they die? Capsule depressurization.
Yes. And listen, remember, this is a key thing. This is the entire opposite of what happened to the Ocean Gate submarine, right? That was implosion. This would have been pressurization, and this would have been. So they would have probably expanded and boiled, yeah,
and froze.
Yeah. No, it's important to know. I think so. The next one about the Bootes void. Did I do that right?
It was a little closer.
Okay. Is a void of galaxies. So that's the cosmic web of our universe. There's this large void of galaxies.
Huh?
Huh? Well, yeah, I mean, there are a bunch of stars, but, you know, a cosmologist will come in here and tell you why they're different. But luckily, they're not here right now, so you're good. All right.
What was question 5? Which star got dim? Beetlejuice. Third. That was the third one. He's here.
No, there's a time limit. It resets after a while.
It dimmed for who knows why. Is it going to blow up? Who knows? We won't be around. Did it return to the original brightness? Yes. Yes, it did.
Yeah. So maybe it was aliens. You never know.
Who knows? Maybe it was astrophage.
Astrophage.
And Ryan Gosling went and saved the day.
Yep. All right, question 6. The sad song, Black Hole Sun, which...
Is it a sad
is it a sad song?
That's what, is it a sad
It's
song?
a slow song, but the only reason I know this is because at Sweary, we have a band they do every Christmas party,
Yeah.
and they're called Space Garden. So the answer is Soundgarden. Won't and take away the pain, wash the pain away.
Wash the pain away.
Yeah, okay.
Yeah, he got there.
Very good.
Who is it?
What? Soundgarden.
Oh.
No, I was saying because we have Space Garden at Sweary.
Yeah, but they've changed their name to...
Again?
Oh, what were they before then?
Space Jam.
Oh, okay. They were Space Jam, now
They
they're
were Space
Garden.
Jam and now they're Space Garden. So, who knows what their third one will be? Space Rat. It's going to be the third one. That's a Parks and Rec joke for those of you who...
Space Rat.
Yeah, like Mouse Rat. All right.
Mouse Rat.
Bonus.
The bonus goes in the bonus section because that's the bonus question. 150,000 miles per hour.
Holy moly.
Fast, very fast. If you're curious, escape velocity, 11 kilometers per second. That's 25,000 miles per hour. So this thing was going stupid fast.
Yeah, so it's not outside the realm of possibility that even with drag and everything, it probably Well, wait, isn't it?
That's our interstellar object for the next.
It's a manhole cover, though. Isn't it made of metal?
Oh, yeah, it'll. That's fat. That's a lot of energy.
Yeah. I know. But
We got
that's
metal.
rock.
No, that's metal.
It's both.
Oh,
We got
well,
whole ass metal meteorites.
fine. That's true. There are metallic asteroids. Yeah. Well, that's why those are fun. You can find them with magnets.
That's why they're fun.
But, huh? Yeah. So,
All right, so we know who's who, so
Yes.
we're divvying up the prizes the way we see fit to give some fairness out. You'll understand.
all right. The winners of the Comet,
Who
right?
got first place? Or no, third place.
No.
We start with third
the
place.
winners of the Comet. No.
No.
We're going to go by the winner. We're going to go by prize or
No,
by
yeah, third place. We go by third place.
Oh. The third place winner is, and you're winning beautiful lunar orbiter posters. Thank you to Robert Reeves. Alien spy ship. Who are you? Okay.
We got him too. We tried to think about who has lunar posters already.
Have you all won those before?
Okay,
No?
good.
Okay, good. Okay. All right. Our second place prize is Interstellar Travelers. And they're, no.
No.
They're going to get to
choose your
choose a
posters.
beautiful poster from our poster collection. So where's our bag? Over there.
They've won a. No, you tied for first.
And
The whole
then
thing. We've been
our-
through this.
our top winner, well, they pick out their poster, who will win this very nice Juice poster here. Juice UVS was mentioned today. Pippa's all happy. The Star Master, come on up. Congratulations.
You have a lunar print, right? Yeah. Okay. Yeah.
Yeah. So enjoy this Juice poster. Everyone, thank you so much for attending tonight. We hope you had a great time for this different AOT. Next month, on April 1st, we'll be back to our usual schedule of 2 speakers. However, It will be April Fool's Day, so maybe we might throw some wrenches at you. We'll see what happens. Good night.